Hello everyone, this is Official Sando. Today I will go through Leetcode 710, random pick with blacklist. Since it's related to the random concept in mathematics, it frequently appears in the AI domain interview. However, I think this problem also can help for coding interview, so I mark for this problem with both topics. If you like my videos and want to support me, please subscribe my channel or click like for the video so that more broader audience can find this video. You can find complete codes and all of my video list in video description below. First, let's look at the description of the problem first. Actually, we can directly jump into the first example. So here we are given as input 7 means we can output any numbers in the range from 0 to 6, and it also gives us a blacklist, which means when we randomly show our number within 0 and 6, we should avoid outputting 2, 3, and 5. So then here the system's recursively call amount of peak function. The output can generate random number 641, 7164, but you will never see the 235 will be in the output. Also, when we're talking about the random peak, means all the number need to be output in the same probability. Next, let's look at how we solve this problem properly. I'm expanding by take the example 1 as example. We are given the range from 0 to 6 and the blacklist 2, 3, 5. Then the idea is we should kind of generate a shorter range by excluding the blacklist. In these examples, we'll generate a shorter range from 0 to 3 since we are blocking the other three numbers. However, there will be the blacklist number in our shorter range, for example, 2 and 3. So we are trying to map in 2 and 3 to other value numbers in the other side of boundary. For example, we can mapping 2 to 6 and mapping 3 to 4. Then 5 is already in the outer range and also in the blacklist, so we don't need to worry about 5. Then the way to build this map, I show in below the code snippet. When we're building the map, we of course we are using unordered hash map, name as m. Then we need other helpers variable. One thing we need to note, there's some rules we need to be careful when building the mapping in this problem. First, we should only build a mapping within boundary. For example, for the number for 5 here. So it's already in the blacklist. So we don't need to build a map for that. Also, second rule, don't build a mapping with elements already in the blacklist. For example, if we want to build in 2, we shouldn't build a mapping 2 to 5. We should choose 2 or 4 or 6, etc. And we also trying to don't mapping the duplicate numbers so that we can have a pointer point to the end of this range and doing the decrement of the range so that we don't need to avoid that. Then for this if condition here is help us to satisfy the first rule. We only do the mapping for the numbers for the blacklist numbers within this boundary. And this while loop help us to find the correcting numbers outer boundary to be mapped, and from the decrement policy. Then let's look at how this examples mapping has been built. So first we has a ordered hash set to install the blacklist number in a increment order, so that we start from 2. Then okay, so now let's generate a boundary between 3 and 4. So we put the value number here, so that if number smaller than value numbers, we only generate a mapping in this range. So then for we start index 6, then we go into this S loop. If the 6 is already been mapped, oh sorry, whether 6 is already in the blacklist. Right now it's not, right? So we only have 2 and 3, 5 in the hash set. So 6 is not there, so we can map 2 to 6. Then we also need to decrement the index after we put in the map. So right now index becomes 5. So then next we populate the second number in the hash set, 3. Then in this while loop we check whether 5 is already in blacklist. It is. So we find the next one is 4 then. So 4 is not in the blacklist, so we can mapping 3 to 4. Now the last number in the blacklist is 5. Since 5 is out of the boundary, we don't need to do anything, right? So eventually we are building this mapping relationship, and we only do the randoms query inside this short range. Since the total valid number is this range, so we can just use random functions to random any of these elements. If random to the numbers in the mapping, so we just output is what's this numbers mapped. In these ways, we can generate the numbers we want to output in the same probability. So next, let's look at the code. In the constructor, we build in the map relationship and save in the m variables. Is what we described in the last slide. Then we provide a pick API to get a random index within the random numbers range. Then if this index is in the mapping relationships, we return the mapping index, otherwise directly return it. Finally, let's look at the computation complexity. The biggest complexity happens in the construction. So S is ordered hash set here, so we put every number in the blacklist in the S, which means we do the sorting of length of S. So if we denote blacklist length is m, so sorting is m log n. Then for the second for loops, basically we iterate the whole blacklist in S. Now here we have while loop here. So it's possible we need to iterate the whole n range, since we're trying to, for example, if the hash set is full of the length of n, then we need to iterate the whole array. So in totals, this second for loop mostly will have big of O n operation. Then the total in the construction is m log n plus n. In terms of memory complexity, we open a hash map m here, and mostly will save the m size, blacklist size key, so it's big of O m. All right, that's all I want to talk about today. If you have any comment and any other problems you want me to explain, please leave your comment and see you in next video.